Aïssata Maiga lets me know how to make bots without Arduino. Writing Rust to move her bot to my groove. Sure, there will be some cool stuff to see, no?
Hello, I'm Aïssata Maiga, just your regular computer science student, and I live in Sweden. I discovered Rust this summer and immediately fell in love with it, like a lot of you in the audience, I'm pretty sure. So let's just start. This presentation will be about making a robot in Rust and working with no-std. It's a fun project to try for yourself or with children. It's also very easy. The most intimidating part is just to get started and order stuff from the internet. I will start by showing you the robot and then explain everything you need to know about every part of the code and share a lot of mistakes I've made, and then there will be a little surprise. I used the crate Averal in that project, and I got a lot of help from Rijks, who is the creator of this crate. So it has great documentation, a lot of templates, how to start your own project, and of course how to configure your cargo file, and basic templates. But it also has many examples for every Arduino board. So for example, I'm using a Uno, and if you go to examples, you can check how to blink a LED and implement it directly, which is traditionally the hello world of embedded systems, I would say. So it works great, and I really recommended it heartfully. The component first. With time, you will notice that all components are standard and pretty much the same. But the easiest way to get started is just to buy a kit. Many are available on Banggood, eBay, or Amazon. So if you just Google Smart Car Arduino or Electronic Smart Car, you should see a bunch of suppliers from which you can choose. The cheapest start at around 10 or 15 euros. If you want to assemble, it's the same. If you just Google assembly Smart Car Arduino, you will have a lot of really good video. I also link them in my repository. Then a word of caution and a good opportunity to share my big error number one. In most assembly videos and on the repo, there is usually schematics that follow. You must be very careful to follow them and to plug things as they look on the image. But the most important is to make sure that the circuit is grounded. That means that all ground cables are connected, that the circuit has a common ground. If not, bad things will happen. Bad things also called undefined behavior. So if you are here and nothing is working and you are getting frustrated, just check if everything has a common ground. Arduino is ideal to begin this kind of project. They are relatively affordable, and there are tons of tutorials on robot making with Arduino. What is great with the brand is the ecosystem, all the libraries and the IDE. But we can't use that in Rust, and that's where Averal has you covered. Arduino is using an 8-bit microcontroller called Aver. From the Aver family, I meant. The one on the Uno and the Nano is ATmega 328P. You can access it with GPIO, which has the general purpose input-output pins, those little holes, and other protocols. So what do I mean by that is you are not programming all the board, but you are programming the microcontroller. This one that you can see here on this board. There is Arduino and Arduino, as we can say. When you will order your kit, it will come with a board. It is a clone, and it works as well as a regular Arduino for this kind of project. I will now tell you about the servo motors, but also the timers, which are very important in this kind of project. I will, of course, show you what I mean with an animation at the end of this slide. So the servo motor is a simple rotating motor, but we do not need it to go all the way to obtain the rotation. So we can think of it as a light dimmer. We will use something called pulse width modulation. If you're having some nice romantic dinner with your partner, you need to control the light, right? And this is what we're going to do. We're going to control the duty cycle. Duty cycles are nothing mystical. It's the fraction of time where the signal is active. In other words, we're going to tell the microcontroller how long do we want the signal to be active. Now, prescaling. All microcontrollers have an internal clock, and the internal clock of the ATmega 328P is 16 MHz. We define a period of time as 1 divided by frequency. So 1 divided by 16 million is really fast. It's 16 nanoseconds. We can't work with that. Even if we multiply by 2 at the power of 8, which is the size of the timer register, it will overflow in a few milliseconds. So now is a good time to share a big error number 2. On the microcontroller, the timers do not all have the same size, so you must make sure that you are doing the calculation with the right timer or the right size. If nothing is working and your calculations are all wrong, it might be the cause. So we are going to reduce the frequency by dividing it by 1024. We then can work with a cycle of 16 milliseconds. Why do we do that? Most servo motors have a frequency of 60 Hz and short duty cycles. So for example, to center it, you need to set it high for 1.5 milliseconds. So 1.5 divided by 16 times the size of the register is 24 ticks. So let's go and look at some code. So this is the code for the servo motor. So first, the magic numbers that we calculated together. So to center it, we divide the time that we found in the datasheet with the prescale period times the size of the register. And then we declare a mutable timer, a mutable pin. You note that the timer is prescaled with a factor of 1024. And then the mutable pin is D3, and then we enable it. So how do we know how to do that? We can go into documentation, and you can see here that I just follow the documentation. Please note that RAIX is using timer 0 and pin D5, and it's very important to choose them right because they are hardwired actually. So this is my big error number 3. So timer 2 that I'm using is hardwired to pin D3. So if you are going to use another timer for the servo, you have to make sure that you're using the right pin. So if we go back to the code, so here you see that I just have a mutable delay to make the rotation not too fast. Then we just set the duty to 15 ticks. So we set it right. That's why we use constants. So we set it right, we wait a bit, we center it again, and then we wait a bit for 100 milliseconds, and then we put it to the left. And I'm going to show how it looks like. So now the sensor. So you can think of the sensor as a bat. A bat sends sound wave every now and then and wait for them to return to calculate how far is it from an obstacle. And this is exactly how it works. So we need to send sound waves about every 100 milliseconds. The sensor has a trigger and an echo. The trigger turns it on and sends a sound wave. When the obstacle is met, the sound wave will bounce on it and return as the echo, and we will measure the length of it. There are many details, but I will just cover the ones I will show in the code. We will use a timer, another timer, timer 1. This one does not need as much prescaling as timer 2 that we use for the servo, so we will just make it 64 times slower. So another magic number that I would like to explain is 58 that you will see in the code. So the sound is traveling 340 meters in 1 second. It will bounce on an obstacle and come back. So we need to calculate 34,000 divided by 2 in milliseconds. So it's going to be 0.017, which is the same than 1 divided by 58. Also, every tick is 4 milliseconds, so you will see a multiplication by 4 that is suspicious. You do not need to pay attention to all those details. I just explained the magic numbers because I know some of you are interested in them. This is the code for the sensor. So we are using timer 1, which is 16-bit, and we're prescaling it with a factor of 64 here. We declare a mutable trigger that I connected to pin D12 and configured into output. All pins are input by default. That's why you need to configure it into an output. And then you need to declare an echo that I connected to pin D11. So you don't need to configure it into input, and because they're all input by default, and then you don't need to have it mutable because we're just going to monitor how long it is high. Those in the comments are commandos to get your console working. So with you can get the address of your Arduino, and then if you type screen, then dev.tty, and then the address of your Arduino with the baud rate, you can see everything showing on the screen. To see things on the screen, you will need a serial. So with a receiver, a sender, and a baud rate. So this is nothing to worry about. This is something that is described in the documentation. So if you just copy paste declaration of a serial, it's going to work. And then in an infinite loop, we're going to write 0 unsafely to the timer, set the trigger high for 10 microseconds, and then set the trigger low again. So this is going to send the sound wave. Then we have to manage an eventual error with the hardware. So if we have waited for more than 50,000 ticks, it means that we have waited for more than 200 milliseconds. So this is probably an error. So we need to use to exit the loop. Since Rust is allowing us to name loops, we just write continue to where, we continue to the outer loop. If not, if we have detected something, we just write 0 to the timer register, and then we monitor how long the echo is high. It means that we don't do anything while the echo is high. Then we get the number of ticks in the timer register divided by the magic number 58 and multiply it by 4 because the unit is 4 milliseconds. And then we wait 100 milliseconds between two sound waves. So 100 milliseconds is corresponding to 25,000 ticks. And at last, we print on the screen how far we are from the target. Now, I want to show the motor driver. Alicia White said that the first time you will see a motor move because you decided it, you will be hooked. The Arduino does not have enough power to move the motors, so we connect it to the driver and connect the logical pins to the Arduino, which means that you will be plugging the cable for the wheels in those two. Those are to communicate with the battery, and this is a 5-volt logical pin that I'm going to use in the demo. There are also enable pin to control the speed, but this is going to be for Rusty 2.0. So now it's time for the walkthrough and talking a bit about no-std. So why do we have to work with no-std, which is Rust no standard code? On the microcontroller and in embedded, there is no OS to allocate memory on the heap. That means that we need to do it ourselves and to indicate to the compiler that we're going to work with a no-std and no main. We also need to build with cargo plus nightly build to indicate that we're going to use nightly. To get the cargo toml configuration, you can again go to Averhal documentation here, and everything is explained in point 5. This is what you need for your cargo file. So we can go back to the code. So we're going to, because we're in no-std, we're going to need to import a panic handler. So panic halt here. And those two are the crates that I'm importing from Averhal to make it work. Those three crates are modules that I used to separate my code when I was refactoring, because I thought that it would be more clear, and also because I was training with Rust data structures. To make it work, you will need some constants. How long do you want your robot to wait between two actions, the minimum distance you want it to have between itself and an obstacle, and what is an acceptable distance to make an alternative choice. So this macro is an attribute macro. Since we're working with no-std, we have to indicate that is the point of entry of the code. And the exclamation mark here is a never type. It means that nothing should return from this function. So we start by downloading everything we have on the MCU. And then we collapse all the pins into a single variable that we're going to use here. This is the general timer that has been prescaled by a factor of 64 that we're going to use mostly with the sensor, but also as a general time checker for the whole project, and then the timer 2 and its pin D3 that we're going to use for the servo. Then I created a servo unit and a sensor unit. This was mostly to work with Rust data structures. You absolutely do not need to do that. It's going to work fine. Then I connected those logical pins to D7, D6, D5, and D4 and gave them very long variable names to refer to each wheel. And then those pins can be downgraded. Downgraded means that they can be put in a mutable array that we can send to other modules to modify them. But wheels is still the owner of those wheels. And then the infinite loop that is going to control a robot, it's still called outer loop, and it starts with the servo unit that is rotated to the front. And then the wheels are going to move forward. We're reading the value with the sensor continuously, but if the value is smaller than the minimal distance that we decided, then we're going to stop the wheels. I'm going to show a bit later how to stop the wheels, and then check the distance at the right. We're going to use to turn the servo to the right, get the value here, wait between two actions, and then do the same for the left. And the rest is just a if-else sandwich. If the value on the left is bigger than the value on the right, and if it's an acceptable distance, like if there is not another obstacle here, then we're going to turn the wheels left and then continue to the outer loop. That is, go forward. Else, if the value on the right is better, then we're going to turn right and then continue to the outer loop. Else, we're just going to go backwards and turn right. So I'm going to show the motor. I think this is the only thing that I didn't show. So we can decide the constant for how long do we want our car to turn, and moving forward, it's just receiving a mutable reference to the wheels. This type seems really, really long, but you know how you do with Rust when you don't know a type. You just declare another type and the compiler is going to complain and give you the right type, and then you can just copy paste it. I did some unpacking here. I put the wheels into a new array to make sure that I write it correctly. And then you just need, when you go forward, you just need to set the forward, the left forward motion and the right forward motion high, and the left backward motion and the right backward motion low. And to turn right, you need to stop the wheels. That is exactly the, I mean, to stop the wheels, you just need to set all the pins low, right? I just removed it from the presentation for a clarity. And to turn right, you have to set the left forward wheel high and the right forward wheel low for an amount of time. So if you move the left wheel, the robot is going to turn to the right. You need to know where to find help. Actually, if there is one thing you must get from this talk, is where to find help. The Rust community is very welcoming, and one of their core values is to provide a safe, friendly, and welcoming environment. This is a community in which I felt safe and comfortable from day one. You can ask any question on the community forum. Then the Rust Embedded Working Group is also living by those values. Overall, people have been providing me with technical consultancy as well as psychological support since the start of my adventures in Rust. When I arrived to the embedded matrix, people realized I did not know anything and sent me to do some homework, but helped me anyway. I want particularly to thank Raix, who mentored me, helped me with his great Averall and my code. So that's it. Thank you very much for your attention. All the project is on GitHub, so please don't hesitate to do whatever you want with it and show me what you did. You can ask me any question you like, and I think that's it. Thank you very much again, and it's time for the surprise.
They see me rolling, they're loving, patrolling, wanna see me riding rusty, 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 my servo's whirring, lights blinking, they're thinking cool to see you riding rusty, wanna see me 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 riding rusty, my list is showing, I'm moving, moving, wanna see me riding rusty, 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 my code is so safe, feel it now that I am riding rusty, wanna see me 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 riding rusty.
That was incredible. It's so good that you all could not see me during the talk because it was just me grinning from ear to ear and like clapping my hands off. Whew. I said I was excited about this talk, but wow. Thank you so much, Aïssata. That was an incredible talk. And yeah, like you mentioned the community at the end and your love for it and your being such an integral part of it, at least to me, shows so much because it's that spirit of like, you just held our hand through all of that. If somebody wanted to try that out, you were like, I messed up here, there, and, you know? Thank you so much. That was really, really great. And as a special treat, I mean, besides the amazing ending, Aïssata is actually here to join us for a live Q&A. So I'm going to add her on now. And we had a lot of questions in the chat, so we'll try to get through as many of those as we can. So hi, Aïssata, you're live with us now.
Hello. Thank you so much. You're a fantastic host. Fantastic. Sorry, I'm all confused with English right now.
I mean, you had to watch your own talk. I don't know how you could do that. Personally, I can't.
Yeah,
there's the recordings on YouTube. Don't ask me to.
Oh, my voice.
No. What an amazing talk, really. I was so excited. I absolutely called dibs on introducing and being here for this talk. In the chat, you actually mentioned that you were kind of cringing because there were some things you would have liked to correct. Do you want to do so now, just so we have it, like, you notice these things, you don't need any angry, there's not going to be any angry YouTube comments, but, our community is great, but...
Yeah, that's true.
Do you want to do any corrections?
Oh, there are so many. At some point I say something about this sound, and then I jump from 340 to 334,000, and it's because, it was really weird. It's because I was talking in meters and then in centimeters, and I forgot to do that, to explain it. And then, I don't even know what to say. And then I saw that in my comments, I read something about the god bat. That was embarrassing. Like, how to be a god bat. I meant that the sensor is working like a bat. And, well, let's just forget that.
If it's fair at all, I think it was very clear. Like, I know we're multicultural and everything, so everyone might not be might not be on the same technological or English speaking level, but I actually thought the two things you mentioned were fairly clear. So, but thank you for clearing that up too.
Yeah, maybe I should not speak about all the errors, but, speak about the community, because instead of speaking about the bad things, the good things, that's true that when I joined the Rust community, it was the only time that I used my own name and my own picture on the internet, and I never do that because, you're always afraid of mean comments and abuse. But yeah, like from day one, it never happened. It never happened, and I felt so welcomed anywhere. I think I made a pull request after a week. So
that's amazing. I know people who've been in the industry for years and years, and they're too scared to make PRs, to put their stuff out there. So that's really cool. It's so great that you actually went for it and that you felt safe and comfortable to do so. I hope, that's why I love your mentoring work as well. You mentioning that and you sharing so much with us, because you're encouraging other people to feel safe, to go for it, to also try it. And that's amazing. So thank you so much. Do you mind if I go into a couple of questions that were on the chat?
No, please. Yeah, my child is here.
That's all right. Don't worry about it. We're all at home. We're all in it together. So I think a couple of fun ones for you first.
Okay.
There was kind of the line of thinking of why robots. Is it hard to start off with something that's embedded, and what your next planned robot is? I think people are very fascinated by the topic of embedded and robots. So please, I saw how excited you're for it.
Yeah. Okay. So what I really wanted to convey with this talk was, it's not that hard. You have to have help, and if you have the right help, it's not that difficult. And the most difficult is really, how do I start with it? And this is what I wanted to show in my talk. How do you get started? And then, I'm pretty sure all of you have your own idea, you have your own objective, you have your own crazy stuff that you want to implement, talking robots. So I don't know. Every time I speak to people, everybody comes up with great things. So I just wanted to show how, the components that I'm using, how they work, so you can put them to use. I don't know, maybe you want to have a fridge that comments if you open it at night. So
Yeah.
this is something you can do with this stuff. But when
Oh, yeah,
when you know how
absolutely.
to get started.
Well, that's what I wanted to say. Like, watching your talk, I was definitely like, oh, I love that you mentioned where to get the things, how to spot fakes and stuff, because definitely watching your talk, I was like, I want to do something too. Like, I really want to go buy components
And
and
it's
start
easy
making
and
cool
it's
things.
really cool. It's really fun and easy. So please go for it. And then you have to show me. I want to see.
So yeah, thank you for that. Any future plans for more robots?
Oh yeah, I brought my Rudolph to school. So now it's not yet done. As you see, the head is not is not. It can't be close, but this is also you can do that with whatever small board you want, and then a small sensor, and then it reacts to sound, but also to shock. So if you turn the battery on first, because then the demo without the demo is not going to work, and you can put some LED into it, and then program that thing with a few for loops. And
that is so cool. Thank you for bringing it. That's an extra special
Halloween project.
Yeah, I hope. Wow, that's amazing. I hope people are tuning into the Q&A to get to see this. That's so cool. Oh wow! Thank you.
Thank you too. I'm all sweaty and happy and.
Oh, that's just part of being the community and part of, getting to partake in this. So I think I wanted to jump on some more technical questions, but I think we actually have to go to the next talk. But I mean, you got to show us the next project, so that's super cool. Thank you so much for joining us. Thank you for everything. I'm just, I'm so happy to be here. It's been so amazing. Thank you for being here. We'll see you in the chat, right?
Yes, I will stay here.
Wonderful. Thank you so much for joining us again.
I mean, not bye, because we'll be in the chat.
We'll see you in the chat, exactly.
Yeah.